All right, in this video, we're going to be continuing with trig functions and looking at their graphs. So in all of these activities on Delta Math, we're going to be basically figuring out how transformations of these trig functions tie into their equations. So we're just going to basically doing some guessing and checking by modifying the original parent functions to get it to match. So our goal is to make this black function here, which is the cosine function. So if you remember, cosine starts up here, looks like this, right? That'll be cosine, and then sine, very similar, except it starts at 0 and does the same sort of pattern. Remember, they go up to 1 and down to -1. So those are our two parent functions, which is what we have here in the black, right? We have a cosine function. So basically, we need to figure out how can we transform this to make it look like that dotted one. And how we're going to do that is making some changes by plugging some numbers into these three gaps here. The equation form that we'll explore more in the next video looks like this: a sine bx plus c. And you can see how those sort of match up with these three boxes here. So the a in the front, that a is going to change the amplitude. That affects the amplitude. For the b, that is going to affect our period. So b, the period actually doesn't equal b, but b just changes the period. There will be a little bit different formula we talk about in the next video about how we actually come up with the period. And then the c, if you can remember back when we did different types of transformations, if we add a number or subtract a number on the end, this could be plus or minus really. So the c is going to be a shift up or down. So those are the three ways that we can change this. The amplitude is going to make it taller or shorter. The b, changing the period, that's going to like stretch it out or shrink it. So stretch or shrink, and that's horizontally. So this amplitude is vertically. And then the c, the shift up or down, is pretty self-explanatory. It moves the function up or down. So in this particular function, if we're trying to move it to the dotted one, we're definitely going to need to move it down, right? And let's go ahead and just try some stuff. You can just plug numbers in here, and then you click try, and then it will move it down, and you'll see if you're right. So move it down to, all right, it looks like we moved it down the right amount, but we also need to change the amplitude of this. Because if you remember amplitude, we find the middle of the function, which the middle of this dotted function would be right here. And the amplitude is how much to the top or to the bottom from the amplitude, from the middle. So it's 2 in either direction. So the amplitude is 2. And so we're going to throw a 2 in front of here and try it now. And there we got it to work. So then you're just going to click submit after that. So our next one, again, the things that we can do to this, we can change the amplitude. So this is going to change the amplitude. This changes the period. And this shifts up or down. So it looks like a pretty similar one. It might be exactly the same, actually. We're going to shift it down. Another thing you can do is you can find the midline on this given one, compare it to the midline of this one. It looks like we're actually going to be shifting it down 3 on this one. We're going to shift it down 3, and then you can find the amplitude of this one. Amplitude is 2, right? Because you can see it's 2 from either one. So we want to put a 2 in front, and then we want to shift it down 3, so it's going to be a -3. And we'll match. The first section of this is pretty straightforward, pretty easy. Let's see if we can get a slightly different one. All right, this is an easy one. It's just shifting up. It's just going to be shifted up 1 spot. And you can see there's not anything we're doing to the amplitude. It's just basically shifting up. So this is the first round of problems. Pretty simple. Let's go ahead and try some harder ones. Level 2. All right. Do a little bit more challenging one here. Okay, this one looks a little bit more challenging. Looks like we need to move it down some. And it also looks like we probably need to change the amplitude. So again, one strategy you could do is just on this new function, just identify the midline. Looks like the midline's right there. Actually, I think the midline, yeah, it's the midline. And then it's up 3, 1, 2, 3, and down 1, 2, 3. So yeah, amplitude is going to be 3. And if you notice, the midline is at -2, so that basically tells us we're going to shift it down 2. So in -2, and then an amplitude of 3. I'm good and give that a shot. And there we go. All right, let's see if there was any. There we go. Okay. So this one throws an additional little wrinkle. If this one, let's say we try to make it work, we know we're going to have to shift it up. Looks like the middle of this one here is at 3. So I'm going to shift it up 3. See what happens from there. Okay, it looks like we need to change the amplitude to 2. But even when we do that, it's still kind of the reverse. So think back what you remember from earlier this year. What we actually really need to do is reflect. So in order to reflect, we're just going to put a little negative sign in front of the A. Remember, negative signs make it reflect. Just going to throw a negative in front of the 2 there. Try it now. That'll flip it around. And there we go. So in level 2, those are the possibilities. You might have to reflect it, still change the amplitude, and shift it up or down. The last problem set will be maybe the most challenging one. This one you can see we might have to stretch it horizontally or shrink it horizontally. In other words, change the period. So in this dotted one, the period of this sine function is actually 12 pi because it ends there at 12 pi. So we need to stretch that thing out majorly. And we also need to shift it down. So let's try to go ahead and shift it down first. Looks like it needs to be shifted down to -2. I'm going to go ahead and do that. The amplitude actually looks fine because that doesn't go any higher or lower. So the next thing is how do we stretch this function out? Because we need to stretch it. So you might think, well, let's throw in we'll just say throw in a 3. We throw a 3 in there and try it. A 3 is actually going to shrink it even more. So the other option would be, well, if a big number like 3 shrinks it, then let's try 1/3. Let's see if that does anything. So 1/3 actually does stretch it. It didn't stretch it enough, so let's try like 1/5. Still not quite enough, so let's do 1/6. I'm just making smaller and smaller fractions, if you can tell here. And that did it. All right. So you'll notice with this period, with the B, a whole number like 3 or 4 or whatever, that actually is going to have the opposite effect of what you think. That will actually shrink or compress. The reason why is because it's inside of the function. And if it is a fraction, like say a half or a third, that is actually going to stretch it. So kind of a little key there for your B's. If you want it to shrink, you're going to use a whole number. And if you want it to stretch, you're going to be using a fraction for that. So let's see another one here. All right, so we've got the solid one as our current one. We need it to match the dotted one. So we do want to compress this one, right? We want to compress it up. So let's throw a number in there, like 4. See what that does. Probably not enough, but let's go ahead and stretch this higher too, because you can see the amplitude of the dotted one looks like it's going to be 3, right? Because we got go down -3 and up to +3. Let's throw a 3 in there. We're pretty close, so let's try slightly. Let's try 5, see if that works. And that did it. So you just got to play around with it until you get one that works. All right, I hope this is making sense. Okay, so we can do one last one here. This one, you go ahead and try it on your own. So on this one, you got to shift it up, and then you're also going to have to change the period. So we're going to be shifting up 2. That will get on the same level. We are going to need to change the amplitude as well, because this one has an amplitude of 2, the dotted one. So throw it 2 in front. And then finally, we need to compress it. So when we compress, we want whole numbers. So let's try 4. See if that does it. Not quite. Let's try 5. If that doesn't work, we'll do 6. Click it as 5. All right, so 2 cosine of 5x plus 2. All right, that does it, guys. Let me know if you are struggling or you need any help.